Okay, we're going to try this again. We're going to go through and do the homework from week 3. And we're going to do this. I'm going to show you how I would do it. I'm going to use Excel to do these problems. So the first problem that we're looking at is problem 4-5. What we are able to do is do all of the problems from chapter 4 in Excel. So we'll go through and do these. The way that I will show you how to do these, we will be doing that, and we'll be using the function key. The first thing to do is click on any particular cell. The actual cell does not matter. Then we will click on the function key, and it will open up a box that will give you a list of all of the various functions that are available. Now, for our purposes, we're going to use the financials. So we'll open this drop-down menu and click on the financials. And looking at problem 4-5, it tells us what is the present value. So it's asking us for a present value, so we're going to solve for present value. So we're going to go down here and find present value, which is PV, which is the present value. And we can put the numbers in here as they are requested. So the first thing we have is the rate, and the rate is 5%. The number of periods is 14 years. Payment is 0, and the future value is $1,500. And it will give us an answer of $757.60. You'll notice that the number is negative, and the purpose for that is that if the present value and the future value need to be in different signs. If one is positive, the other one needs to be negative. So if we go back in here and we change the future value to a negative 1,500, you'll notice that that changes it to a positive. That will become important later on, but at this point, just recognize that one has to be positive and the other one will always be negative. Okay, now the next thing we're going to be doing is we'll do the part B, which is the function whereby we'll change the number of years or the interest rate till 10%. So we'll do this the same way. We'll come on down to the present value. The rate now is 10%. The number of periods is still 14 years. Payment is 0, and the future value is still $1,500. And it will give us $395. So those are your two answers for problem 4-5. Now for 4-7, we do exactly the same thing, because now we're looking at the present value for 2,500 with a future value 2,500 and a 5-year time span. So we click on the same box. We come on down here to the present value. The rate now is 9%. The number of periods is 5 years. Payment is 0, and the future value is 2,500. And that gives us a value of $1,624.83. Now, for part B, we change this to quarterly. So we again do the present value. The rate is 9%, but now it's quarterly, so we have to adjust the interest rate. So we adjust the interest rate by 4. So we divide that by 4, and that changes it to 2.25%. You can see that off here to the right. Now the number of periods the time period is 5 years, but that is quarterly, so now we have to multiply that times 4, which gives us 20 periods. Payment is still 0, and the future value is 2,500. So that gives us 1,602 is the answer. And then we repeat that now for the monthly calculation. And monthly is, the rate is 9% divided by 12. The number of periods is 5 years times 12 months, and the future value is the same, 2,500, and it gives us the answer of 1596.75. Now the second part of the question, why is the present value lowest when the interest is compounded monthly? It's compounded more frequently. So this problem would basically be saying, how much would you have to put in the bank at 9% in order to have $2,500 in 5 years? Well, the more frequently it's compounded, the lower amount of money that you have to put in. Okay, in the same way that we can calculate present value, we can go on to problem 418. Now we're going to solve not for present value, but the question is, 10 years ago Bruce invested $1,250. Today the investment is worth $3,550, and the interest is compounded annually. What is the annual return? What did Bruce earn on this investment? So now we will go ahead and we'll solve for rate. So we come down here and we solve for rate, and the number of periods for Bruce is 10 years. There is no payment. The present value, now the present value is $1,250. That's how much he initially invested, and the future value is $3,550. And now what we need to do is make one of these has to be negative. So now we'll change this to $3,550, and then we will be able to get that to be 11%. Now, a couple things to show here. As long as one of them is negative, if they're both negative, Excel can't calculate it. But if one is positive and one is negative, we will get the same answer. It's 11%. We can also look to add a few decimal places there by clicking on the percentage keys here, and that will give us a better look that it's actually 11 flat. Okay, 422. Yolanda Bank advertises savings investment that pays 6% compounded monthly. What is the annual percentage rate, APR, and the effective annual rate for Part B? Well, the annual percentage rate, the nominal, is the 6%. It's the nominal interest rate, so it's just a straight 6%. Now we can calculate the effective annual rate, and we can use Excel to do that. We can go down here, and there actually is a particular calculation. It's called effect, and what we can put in, as it says, we put in the nominal rate, which was 6%, and the number of periods per year, and we say it's 12, and it gives us a number of 6.16. We'll change that to a percentage, put a couple more decimal places on it, and it's 6.168. Okay. All right. Let's do the next one. Nola purchased a new car earlier today for $32,500. Right. She financed the entire amount with a 5-year loan with a 3% interest rate, compounded monthly. Compute the monthly payments for the loan. Okay, now we're going to use Excel. We click up here. Now we're going to solve for payment, which is PMT. And the rate was 3% divided by 12. The number of periods is 5 years times 12. The present value of the loan is $32,000. That's the value of the car. But the future value of the loan is 0. When the loan is totally paid off, it's going to be, the loan is no longer has any value. So her monthly payment is $575. Now the next part of the question is how much will Nola owe on the loan after she makes payments for 2 years? That is 24 payments. Now there are a couple ways of solving for this, but what we're going to do is we're going to say, what is the value of the loan after 24 months? So we're going to come here, and so the value of the loan is the present value. So we're going to calculate the present value. The rate is going to stay the same, 3%, 3% divided by 12. Now the number of periods, she's already made 24 payments, so that means of the 60 she has 36 payments left. The payment is $575, so we can put that in as a minus $575, and the future value again is 0. And so that is the value of the loan after. That's how much she still owes. Now she will pay more than that because she has to pay interest. But if she was going to pay off the loan after 24 months, that would be what she is going to have to pay. Okay. Now let's move on to, well, that should wrap it up for Chapter 4. We'll start another video for Chapter 5.